Oh shit. Okay, we are live. I just realized that I was in the wrong scene. Um there it is. Okay. We are live. What's up guys? This is Dem Keys and today fuck dude, it's been what 10 days since I streamed? Like holy shit. All of this time like I've been trying to find a day to stream. I've been trying to find like a suitable time to stream, but like it just wasn't happening. And then I just got carried away with other stuff. But yeah, I think I did this off stream. Like in the meantime, while I wasn't streaming, I was still carrying on with my Godot studies. And I'm done learning the basics of GD script. So now is the time to do more complex things, start trying to build systems. So the first thing I wanna tackle is networking. Also, I want to do a couple of experiments to see. So I was having this doubt about the scene tree, right? I figured now that I know the basics of GD script, I can probably try enumerating the scene tree and doing my own experiments to try and understand how many scene trees there are, if there's more than one scene tree at any given point, or if the scene tree changes to something else at any point. Yeah, there's so much more for me to explore, and now that I know the basics of GD script, it's going to become a little easier for me to do things programmatically, which is kind of what I'm aiming for. Also, so okay, I'm trying to get into the networking side of Godot, and simultaneously, side by side, I wanna get back into learning about Mediapipe, which is here. So I've been looking into this. I did a little bit of Mediapipe stuff back, like, I don't know, a couple months back, but like I didn't really dive into it, so to speak. I kind of just tested out the sample code that they gave, and I tested out what the final result would be like. So like they gave ready-made code that I could run, and I might have had to make some changes here and there to make sure that it runs on my system, but that's the most that I did. I didn't construct the code myself, and what I want to do is learn how to construct the code myself. To do that, I need to learn about the various systems that are running, the various tools that are available. So like on one hand, you have the actual capture process, right? That is like separate code, and then the visualization of what you have captured, that's a separate thing. So like these are two separate things that I have to learn. They're both part of the same script, but they're two separate things that I have to also learn. So I want to get into these things eventually once I am more familiar with Mediapipe and like running the model and doing visualizations and stuff like that. Once I'm more comfortable with creating my own system to do that, then I will run this code on a separate system, on a separate machine, and send the data over to this machine, which is the streaming machine. I'll send the data over to this machine from the other machine. So at that point, I should have tracking data successfully being sent in from another system. And once I have that, I can start doing body tracking stuff in Godot. Give me a second, let me hydrate, and then I can carry on talking. Okay, so I don't know how long I'm gonna be able to stream today because I haven't streamed for 10 days, and because of that my voice is kind of, it needs to get used to talking a lot more again. It's kind of weird, dude. Like it takes me weeks and months to sort of slowly build up that tolerance to be able to talk longer, even with this method that I have of hydrating every 15 minutes. It takes me like weeks, if not months, to build up the tolerance, and then I don't stream for like 1 week or 2 weeks, and all of a sudden that is just gone. I have to build it up again. Anyways, it is what it is, dude. I've also been looking into Resonite. I've been doing a fair bit of stuff in Resonite. It is amazing. Resonite is crazy. One of these days I want to do Resonite building streams, cuz like, dude, Resonite is crazy. Like, you can do everything within that application itself. If you know about Neos VR, it's very, very similar to Neos VR. I don't know anything about Neos VR, but what I do know is that this Resonite and Neos VR, they share a lot of similarities, and even on the development side, the logic building side and all, they share a lot of similarities. In fact, a bunch of the devs of Resonite are ex Neos VR devs. So like, it kind of makes sense that you have like a similar kind of system being built. That being said, I never got into Neos VR. I never got into Neos VR when the platform was in its prime, I guess I should say. And then a couple of issues happened with the platform. Like, I was so not into Neos VR that I didn't even know that some shit happened with the platform. But yeah, some shit happened, and now we have Resonite. Neos VR is doing their own thing. Resonite is doing their own thing. I'm way more interested in Resonite. I've looked into, like, I'm to be honest, I'm not even remotely interested in like the social aspect of Resonite. I'm mainly interested in the development tools. Like, all I do when I open up that game is just go into my own world and start creating stuff, start messing around with the development tools. Oh yeah, I guess in a way that brings me back to Mediapipe, because I want to capture body tracking data and send that into Resonite as well. Because the great thing is, dude, it is amazing. Like, I was amazed by seeing the development. I don't even know what to call it. The architecture, maybe the development environment, I guess I should say. The tools, let's say the development tools that are available to you. It's amazing because so you can open up an inspector, and that inspector is going to show you all of the I guess in Resonite terms they call them slots. That's the equivalent of a game object in Unity. So there's like there's a root slot, and then there's a bunch of other slots under it. Every single thing that you see in the scene, including yourself, like your own avatar, everything, all of it, you can see it in the inspector. So like, you, the user, you can also access your own group of slots, your own group of nodes, and you can control various things. And that was good news for me, because that means that I have somewhat of a chance. I still need to mess around with it to see to what extent it's possible to do what I'm trying to do. But just the fact that we have access to them, like, I'm able to access hands and the head, like the basic things that get tracked with VR, I'm able to access those things. I'm also able to access. I'm able to read their position in 3D space, their rotation, their scale. Scale doesn't change much, but like the position and rotation is the important part here. I'm able to access those. That's great because currently they're being automatically controlled. Once I can figure out how to override that, I can then send in my own values, and then I can have like my own sort of body tracking setup. I'm sure I'm not the only one who's coming up with this idea. I'm sure there's somebody else working on a similar thing. It's probably gonna look like shit. Like when I initially, it's probably always gonna look like shit. It's not gonna be as good as having VR, but at the very least, I'm gonna be able to control things with my hands. And I want to see how far I'm able to take that, because being able to control things with both of my hands, it is going to give me a lot more, I don't know, I guess fidelity is the right word. Hold on. There was, I need to, hold on. Give me a second. Am I using the right degree of exactness with which something is copied or reproduced? Okay, so maybe fidelity is not the right term to use here. It's going to give me more degrees of freedom. Let's say that. Yeah, let's say that. It's going to give me more degrees of freedom compared to just using a mouse and keyboard. I'll probably still have to use the keyboard, though I can manage. Maybe that's where I can like introduce gestures. Yeah, I can come up with like creative ways to send input. In fact, once I'm done with, once I've learned how to capture body pose and like hand tracking data, I could probably try writing a Rust script that will allow me to control stuff on my screen. It'll allow me to control my mouse cursor, for example, with just my hand. I want to try something like that. Because Rust gives you the ability to, well, not Rust necessarily, but like the Windows crate in Rust gives you the ability to interface with the Win32 API through Rust. And so I can use that along with Mediapipe and Python to get body tracking, to get hand tracking, specifically hand tracking data, and then try to apply that to the mouse cursor position, because I believe you are able to set the mouse cursor position. There is something for that. There is an API endpoint that lets you do that. I'll have to see the method for sending input, for triggering, for example, a mouse click or a mouse wheel movement or right mouse click, for example. I need to figure out a way to trigger the input, because I don't know if it allows you to, if the Win32 API allows you to do like a sort of global mouse click, or if every mouse click is like restrained, or every input is restrained to whatever window is active, in which case like it gets a little bit complicated, because the window that I'm running the script from would be the console window that the Rust script is running in, but I'm trying to send the mouse input to basically any other window. If that makes sense. I don't know if that made sense. But yeah, if I'm able to do that, I think I'm going to be using that a lot. I'm getting excited thinking about being able to control my mouse using my hand. Yeah. There are a few small things I need to look into in Rust. I didn't finish learning about vectors. So far, what I understood is that it's similar to lists in C#. I don't remember exactly. I don't remember if I finished reading it. Like maybe I'm mistaken, thinking that it's similar to lists. I don't remember. And then there's ownership and borrowing and lifetimes. I need to look into that concept again. And I think there was one more thing remaining. I can't remember right now. But yeah, once I've looked into those things, then I'll be ready to mess around with the Win32 API. There's actually one or two more projects that I have that I can do in Rust, which can't really talk about it here, but yeah, there are one or two more projects that I'm excited for. Okay. That being said, let's carry on with this. So here, wait, they are explaining it here. Okay, so I haven't looked at this. I haven't looked. Okay, so I actually no, I have looked at this. So mainly, what I'm looking at right now is, or what I'm looking to do right now is use Mediapipe tasks. Eventually, if necessary, I'll look into Mediapipe Model Maker to create my own model for body tracking. I'll have to see if that is necessary at all, if that provides any sort of benefit at all, like maybe faster inference, a smaller model to run, a faster model to run inference on, or even better, more accurate body tracking with a much lighter load on the system. Like if I'm able to achieve that by creating my own model, then I'm willing to try that. Though I don't think I'm gonna need to do that, because actually I don't know if I'm gonna need to do that. Give me a second. Okay. So the specific solution that I'm looking for in Mediapipe, at least right now, is the body pose thing, I think it's called. Pose landmark detection. This is what I'm looking for. Hold on, there was, I think this is it. Yeah, I think this is the one. Okay. So I'm not sure why it was so zoomed in. But yeah, this is what I'm looking for. More specifically, Python. So they give you the code. I don't know if they've explained the code. I think maybe they've explained the code. But yeah, I wanna look into all of this stuff as well eventually. So for now, I wanna try and get networking set up in Godot. The simplest thing that I can do is set up. So you know what? Okay, I could try setting up a UDP server first. So I've been looking into packet peer UDP, and from what I understand, that's pretty low level. It seems to be similar to creating a socket in C#, because like that's the object. Like you create that object, and then using that object, you can bind to a certain endpoint. You can You can close the connection, of course. You can get data, you can send data. So like I believe that's the equivalent of a UDP socket. And I think UDP server builds on top of that. I could be wrong. I don't know exactly. But I think UDP server probably builds on top of that. I was also looking into packed byte arrays. Give me a second. Let me hydrate. Yeah, I was also looking into packed byte arrays. Mostly because the socket uses this is what you have to pass in when you're trying to send data. I think also when you're trying to receive data. I don't remember. Where is UDP server? I think it was mentioned somewhere here. Where's packet peer? Okay, this is packet peer. Here you have put packet, send packet. I could just Google it. Oh, actually, I could just look here. PQRSTU. Okay. UDP server. There it is. Okay, so I could try with this directly instead of implementing the thing from scratch, but I kind of want to implement the thing from scratch. I mean, this would be much faster, I guess. I could have a UDP server up and running and just see if I have inter-process communication established, and once I have that, then I can try implementing my own bare bones version, because like eventually I am planning on just implementing my own bare bones version to a certain extent. So I kind of want to also use what do you call it, WebSockets. I want to use the WebSocket protocol. Godot provides an implementation of that. Rust provides an implementation of... Well, Rust has one or more crates that provide that functionality. I believe Python also has, like, there's one or more packages that that allow you to set up a WebSocket server. So like if in that scenario, I'm not going to be doing low level stuff. I'm just going to be setting up the server. I'm not even going to be like, in a way I'm going to be implementing the server, I guess, but like it's going to be kind of like using UDP server here, where I just I instantiate the server, and then I listen for data that's coming in and then do something with it. Okay, hold on. Let's read this. But yeah, I do want to look into WebSocket stuff, because I mean Godot provides it. Godot provides an implementation of it, and Rust also provides an implementation of it. Something I wanna look into is the speed. I want to look into the speed of bare bones UDP versus WebSocket. Also, I think WebSocket probably uses TCP, not UDP. I believe it uses TCP, because it requires a connection oriented protocol. It requires a connection oriented socket. Because like you're constantly sending, like even to set up the server, there's like a handshake process that takes place. So like given all of this, I don't know if it gets set up using UDP or not. I could be wrong. Maybe it's set up, but no, I think I remember reading somewhere that it's TCP. Anyways, let's see. Oh, you know what? I could do it here. WebSocket peer. Okay, so let's take a look at this. This class represents WebSocket connection and can be used as a WebSocket client or as a remote peer of a WebSocket server. Oh, so you can use this to set up a client, but not a server? To start a WebSocket client? Wait, no, hold on. You can send WebSocket binary frames using so-and-so, so-and-so, and WebSocket text frames using so-and-so. Okay, great. You can check the frame type of the last packet via so-and-so. Okay, great. So this is talking about setting up a client. What about a server? Let me Google this. Hold on. So Godot WebSocket server. Minimal server example. Okay, okay, so I'm looking at like a class reference kind of thing. That's probably why I missed something here. So let's look at let's go back to the manual, and in the manual section, let's see the networking side. Where is networking? N. There it is. High level, okay, WebSocket, there you go. So the WebSocket protocol was standardized. Okay, this is all, this is history. Oh, hold up. Actually, let's read this history, because it gives some more information. It's not just history, it's giving information there as well. Okay, the WebSocket protocol was standardized in 2011. By the way, I'm probably gonna be doing 2 streams today. I don't know how good that is for my voice, but I'm probably going to be doing 2 streams today, because one of the reasons I haven't streamed for the past couple of days was because of my sleeping schedule. It kind of went off balance, or it moved away from what it usually is for me to be able to stream, because like I have a specific window during like every day. I have like a specific window when I'm able to stream. If I miss that window, I can't stream. Today, at this time, this is a very unusual time for me to stream, but I got the chance to stream, so I streamed. What was that? Why was I saying this? Yeah, there might be a second stream. So like I might stream for another hour maybe, and then I'm gonna stream after 6 hours, I think. Yeah, I don't know what that's gonna do to my voice, but like let's see. Okay, the WebSocket protocol was standardized in 2011 with the original goal of allowing browsers to create stable and bidirectional connections with a server. Okay, before that, browsers used to only support HTTP requests, which is not well suited for bidirectional communication. Alright. The protocol is message-based and a very powerful tool to send push notifications to browsers, and has been used to implement chats, turn-based games, etc. It still uses a TCP connection, which is good for reliability but not for latency. So not good for real-time applications like VoIP and fast-paced games. You know what? I don't think my use case is gonna be so... How do I put this? I don't think my use case is gonna be so heavy on the bandwidth that I cannot deal with like a tiny bit of latency. I think I could try WebSocket. I think I could try it. We can give it a try. We can see what it looks like. If we are able to, let's say I'm able to send. Actually, I could test it. I could test it out with like two separate clients, or well, a server and a client. I could set up the server here on this system. I could set up a client on another system, because I'm assuming the client is only it's only going to be a few lines of code compared to the server itself. So I could test out by seeing how quickly the message arrives from the client to the server whenever I do send it. Because like if I'm sending what do you call it, if I'm sending like body tracking data for, oh okay, there's an ad playing, so I'm gonna hydrate. All right, welcome back. Just give me a second. I need to do something. All right. Okay, so where were we? I forgot what I was saying. I think I was saying that I can set up a WebSocket server and a WebSocket client on like two separate machines, and then send a message from the client to the server and see how quickly the message arrives. Oh yeah, I was getting into the body tracking thing, because like when I'm gonna be sending body tracking data from one client to another, or from the client to the server, I want to have as low latency as possible. So I'm gonna have to see how much latency I'm dealing with, because I can deal with latency. How do I put this? I can deal with the latency if the latency is only affecting my body tracking. So like if I move my hand, for example, and the tracking takes like 0.25 seconds to arrive, the tracking data takes 0.25 seconds to arrive. It's probably going to be faster than that, but like let's say the tracking takes 0.25 seconds to arrive, and so my avatar, for example, it shows the hand movement 0.25 seconds later. That's not going to be that big of a deal, because it's just, you know, it's just body language that's being affected there. It's not that big of a latency. But for example, if I'm trying to use body tracking data to control the mouse cursor, for example, there latency definitely matters, because if I move my hand and there's a 0.25 second latency, that can be a little jarring, at least from my point of view. So like if I move my hand, I want to make sure the mouse cursor is moving immediately. It's not taking time. I mean, to be fair, actually no, okay, I was gonna say, to be fair, one way that I can accomplish this is by by running the model on this same system, but no, I don't want to do that. But yeah, okay, let's carry on. Let's carry on reading. Where was I? Web. Okay, let's take a tiny look into WebRTC. One of Godot's great features is the ability to export to HTML5 WebAssembly platform, allowing your game to run directly in the browser when the user visits your web page. This is a great opportunity for both demos and full games, but used to come with some limitations. Are those limitations gone now? In the area of networking, browsers used to support only HTTP requests until recently, when first WebSocket and then WebRTC were proposed as standards. Okay, so that's how the limitations are gone. Okay, WebSocket. When the WebSocket protocol was standardized in December 2011, it allowed browsers to create stable and bidirectional connections to a WebSocket server. The protocol is a very powerful tool to send push notifications. Okay, I've read this. WebSockets, though, still use a TCP connection, which is good for reliability, but not for latency. So not good for real-time applications like VoIP and fast-paced games. WebRTC. For this reason, since 2010, Google started working on a new technology called WebRTC, which later on. Wait, is this a protocol or is this something? I think this is also a protocol. Let me just Google this. WebRTC. WebRTC is a free and open source project providing web browsers and mobile applications with real-time communication via APIs. Okay, how is it doing that though? It allows audio and video communication to work inside web pages by allowing direct peer-to-peer communication, eliminating the need to install plugins or download native apps. Okay. Supported by Apple, Google, Microsoft, Mozilla, and Opera. WebRTC specifications have been published. Is this a protocol or what? Hold on. I'm trying to understand if this would be considered a protocol. Or is this a... Okay. According to the WebRTC.org website, the purpose of the project is to enable rich, high-quality RTC applications to be able to be developed for the browser, mobile platforms, and IoT devices, and allow them to all communicate via a common set of protocols. Okay. Oh, you know what? I could have just looked at this. Oh, by the way, whatever I was just reading, I was reading it from a different, on a different screen, just in case, it didn't make any sense what I was saying. Do they have a link to the Wikipedia thing? Actually, real quick. So, it says that it's written in C++ and JavaScript. Major components of WebRTC include several JavaScript APIs. Okay. So, would this be considered a protocol, or would it be considered a standard that you would have to create an implementation for? Kind of like OpenGL, DirectX. I think it's the latter. You create implementations for it, which technically you also do that for the protocol. Whatever system you're designing for communication. Let's say if it's for WebSockets, you have to design the system so it sort of adheres to the WebSockets protocol. Web real-time communication. Okay, hold on. Let me open it up here. We can browse the thing here. Let me. Okay, WebRTC. So this is a thing by Google, which is cool. So there's probably going to be like, I'm expecting there to be implementations in multiple languages, which if there are, then that's great. I mainly give a shit about implementations in C Sharp, uh, Python, and Rust, but like C Sharp even less. C Sharp for other stuff, but like, oh, let me. Okay. So, we are here. Let's see. Would it be under design? Okay, major components of WebRTC include several JavaScript APIs. Get user media, acquire so-and-so. Okay. Okay. Wait, this enables audio and video communication between peers. It performs signal processing, codec handling, peer-to-peer communication, security and bandwidth management. Okay, so okay, I don't think this would be considered a protocol. I don't know why I'm hung up on fucking terminology. I find it dumb to be hung up on terminology, but like I'm trying to in in this specific scenario, I'm trying to sort of visualize it because calling it a set of protocols is slightly different. Calling it a protocol is slightly different from calling it a standard. Uh, which it doesn't really matter, right? Okay, WebRTC allows browsers to stream files directly to one another. WebRTC allows Oh, just a second. Just a second. Okay. Yeah, WebRTC allows browsers to stream files directly to one another, reducing or entirely removing the need for server-side file hosting. WebTorrent uses WebRTC transport to enable peer-to-peer file sharing using the BitTorrent protocol in the browser. Some file sharing websites use it to allow users to send files directly to one another in their browsers. Although this requires the uploader to keep the tab open until the file has been downloaded. That kind of makes sense. Kinda? Well, yeah, okay, that kind of makes sense, right? Because there's still the the client still has to be running in order for that download to complete. Which I was trying to visualize it from like the browser point of view. Because like when you start a download, the download keeps running, right? In the background. Okay, anyways. Um A few CDNs, such as the Microsoft-owned Peer 5, use the client's bandwidth to upload media to other connected peers, enabling each peer to act as an edge server. Although initially developed for web browsers, WebRTC has applications for non-browser devices, including mobile platforms and IoT devices. Examples include browser-based VoIP telephony, also called cloud phones or web phones, which allow calls to be made and received from within a web browser, replacing the requirement to download and install a soft phone. Guys, give me a second. Okay. Okay, let me Google something else. Okay, because I'm trying to understand this. Hold on. Have they mentioned how exactly you wait, what is this? Okay. All right. Okay. I mean, this is not really gonna affect me. At least like with my specific scenario, it's not really gonna affect me. Okay, yeah, I was gonna Google is WebRTC a protocol? Is an open source communications protocol that enables, okay, so this is a protocol as well, and then you have to implement the thing based on whatever design they mention in the standard. And the standard is linked here, which I don't think I'm going to be opening. Is there something like I think in the design it mentions here, right? Okay, major components of WebRTC include so and so. Okay, RTC peer connection enables so and so. Okay, RTC data channel allows bidirectional communication of arbitrary data between peers. The data is transported using SCTP over DTLS. It uses the same API as WebSockets and has very low latency. The WebRTC API also includes a statistics function, get stats, allowing the web application to retrieve a set of statistics about WebRTC sessions. These statistics data are being described in a separate W3C document. Okay, okay. All right, fine, great, cool. So where were we? We were here, WebSocket, WebRTC. So I guess I'm going to be looking into both WebSockets and WebRTC. Um, RTC peer connection. I need to, dude, I think I need to read up on the design of, I need to read up on the design of both of these protocols. Maybe let's start with, what do you call it? WebSockets. Browser implementation, protocol handshake. I think this is what I'm looking for. To establish a WebSocket connection, the client sends a WebSocket handshake request. Okay, the client sends a WebSocket handshake request for which the server returns a WebSocket handshake response, as shown in the example below. Client request. Okay, this is all. It's all. This will all be implemented. Like this is all part of the protocol implementation, like so and so. Okay. All right. Great. Cool. So the client sends a request, the server receives the request, and then what happens? The handshake starts with an HTTP request response, allowing servers to handle HTTP connections as well as WebSocket connections on the same port. Once the connection is established, communication switches to a bidirectional binary protocol which does not conform to the HTTP protocol. Okay, but what is the bidirectional binary protocol called? Which protocol does WebSocket use? Well, it says bidirectional. Actually, okay, not just because it's bidirectional, but like because it's connection oriented, so it uses TCP, right? From what? Yeah, it uses TCP. Okay. Where was I? Here. Okay. In addition to upgrade headers, the client sends a sec WebSocket key header containing base64 encoded random bytes, and the server replies with a hash of the key in the accept header. This is intended to prevent a caching proxy from resending a previous WebSocket conversation. Okay, and does not provide any authentication, privacy, or integrity. Okay. All right. Okay. Okay. So it has been 52 minutes that I've been streaming. Is the music still going? It just occurred to me. Give me a second. Nope, the music stopped. By the way, speaking of music, shout out to Machine Supremacy. Go check them out. They've made some pretty awesome music. If you like video games inspired music, you'll probably enjoy their music as well. So yeah, go check them out. Okay, is there something that explains it in just a few lines? Because, okay, so far what I've understood is the client sends a handshake request, the server responds with a handshake response, and once the handshake is successful, then they establish a connection. And further from that point, you can start sending messages. But I need to make sure that that's exactly what happens here. Okay, here it is. The handshake starts with a HTTP request response, allowing servers to handle so and so, so and so, so and so. Once the connection is established, so I'm guessing the connection gets established once the server sends a response. Then the communication switches to a bidirectional binary protocol, which does not conform to the HTTP protocol. All right. Once the connection is established, the client and server can send WebSocket data or text frames back and forth in full duplex mode. The data is minimally framed with a small header followed by payload. WebSocket transmissions are described as messages, where a single message can optionally be split across several data frames. This allows for sending of messages where initial data is available, but the complete length of the message is unknown. It sends one data frame after another until the end is reached and committed with the fin bit. Oh, okay. So the protocol, like it handles that for you. Okay. Client server masking. The payload data sent from the client should be masked by the masking key. The masking key is a 4 bytes random value chosen by the client and should be unpredictable. The unpredictability of the master key is essential to prevent malicious applications from selecting the bytes that already appear. The following algorithm is applied to mask the payload data. Okay. All right. So let's start with WebSocket, and then I'll look into WebRTC once I'm more comfortable with WebSocket. Actually, I need to also look into UDP server. Which one should I look into first? I kind of want to look into both of these and then later on look into WebRTC as well. Because like at the very least, I can set up my own UDP server even without WebSocket and WebRTC. Because like WebSocket and WebRTC are going to be more, I guess, structured. Like it's a more standard way of doing things. Like they've provided a way for you to set up a server. They've provided a way for you to set up a client. And once you've created both of these things, you can then establish a connection and just have communication between them. But like if I'm implementing the thing myself, then I'll have to create the server and client architecture, which is not going to be that complicated because at any given time, I'm probably only going to have one client, which is the other application that is sending in tracking data. If there is a need for another client, then I can change my code a little bit. But yeah, okay. All right, so let's start with the UDP server. So this is a helper class to implement a UDP server. A simple UDP server that opens a simple server that opens a UDP socket and returns the connected packet peer UDP. Okay, upon receiving new packets. It returns the packet peer UDP upon receiving new packets. See also packet peer UDP. Wait, so is packet peer UDP, would it be considered? It says peer, right? So like, is that? I assume that's not the packet itself. That's the socket. Like it's something representing the socket. Okay, upon receiving new packets. All right. See also so and so. Connect to host. Connect to host would be for the server, right? Calling this we are calling this method from where? Packet peer UDP. Okay. Calling this method connects this UDP peer to a given host / port pair. Okay, so this is what the client will use, I'm assuming. UDP is in reality connectionless. Fuck, I forgot about that. Yeah, it's connectionless because like even in C#, you have the option to connect if you want to, but like they also have like the send to and receive from methods. So that way you don't need to connect. From what I remember, you don't need to connect. You can just directly send the data, and then if the server is willing to accept it, if the server is currently trying to accept, it'll catch the data. Actually, I wonder if the server has to be actively trying to accept, or if the server could start trying to accept a couple of seconds later And in which case, like maybe would the message be stored in some kind of buffer in the meantime? I guess I can test that out once I implement it myself. Okay, UDP is in reality connectionless, so this option only means that incoming packets from different addresses are automatically discarded. Incoming packets from different addresses. Incoming packets from different addresses. And that outgoing packets are always sent to the connected address. Okay, future calls to set destination address are not allowed. This method does not send any data to the remote peer. To do that, use so-and-so, so-and-so, so-and-so. Great. Note, connecting to the remote peer does not help to protect from malicious attacks like IP spoofing, etc. Think about using an encryption technique like TLS. I need to look into TLS as well, because I've seen TLS being mentioned in a couple of different other scenarios where I was trying to do some networking stuff. Though, I mean, for my specific use case, I don't need to look into TLS because the data is being sent like on my own network. So and it's not sensitive data. It's not like login credentials and shit. It's like tracking data and messages that's meant to be seen. It's stuff that's being seen by me anyways, so I don't need to worry too much about it. But like for other situations, I do want to look into using and setting up TLS on the multiple languages that I use. C# I believe has its own way of setting it up. I need to see how Rust handles it, how Python handles it. Oh, okay, yeah. There's a remainder of the sentence saying exactly what I just said. Think about using an encryption technique like TLS or DTLS if you feel like your application is transferring sensitive information. All right, great. So after starting the server with listen, you will need to poll it at regular intervals. For example, inside node.process. Oh yeah, in the update method. Okay. I'm still not used to calling it process. Like my mind just automatically connects it to the update method in fucking Unity. In Unity, you have the update method and start method, and here you have the ready method and process method. Okay, yeah. After starting the server, you will need to poll it at regular intervals for it to process new packets, delivering them to the appropriate packet peer UDP and taking new connections. Below a small example of how it can be used. By the way, I also looked into async stuff in Godot. Just like briefly, I kind of like went over it a little bit. They had like a small section for async stuff, and it is cool because like you can set up a coroutine, pause the thing, and return control back to the caller. Carry on doing whatever you're doing. So like in okay, so more what's the word I was trying to use there? To be more precise, I looked into async stuff that has to do with signals. Signals is kind of the Godot version of events. So you can like create a signal and you can emit that signal whenever something happens. You can also connect methods from other nodes to that signal, and then um, whenever the signal is emitted, or the quote unquote event fires, then all of those functions are going to execute as well. And where async comes in here is you can use async to kind of pause the method until the signal is emitted. So you can use it to, for example, wait for a button press, but in the meantime, don't block the entire thread. You just return control back to the caller, back to the calling method, and carry on executing whatever you were executing. And then whenever the signal is emitted, then it'll sort of carry on from where it left off. Give me a second. Let me hydrate. So yeah, I might be able to look into, I might be able to do something with async stuff here. I also need to see, like, how is packet peer UDP handled? Is it like, how is the, in terms of being asynchronous, how is it handled? Because, like, well, okay, no, it does mention that here, right? That is why you have to poll. So every process, every cycle, you poll for new data. If there is data available, then wait, no, poll is for connection. Take connection, get packet. Wait, poll is for okay, call this method at regular intervals to process new packets. And packet from known address. What? And packet from known address / port pair will be delivered to the appropriate packet peer UDP. Any packet, oh, maybe they meant any. Okay. So any packet from known address / port pair will be delivered to the appropriate packet peer UDP. Any packet received from an unknown address / port pair will be added as a pending connection. Okay, I need to experiment with this to understand what exactly is going on here. Okay, how would I be doing this if I was, because, like, this is in fucking UDP server, right? How would I be doing this if I was just doing packet peer UDP? Because, like, packet peer UDP, you can, okay, what are the methods that are available here? So we have bind, we have close, connect to host, and then okay, so all of these are for packet peer UDP. Wait, hold up. Connect to host is socket connected. Okay, I need to look into both of these. And then there's a wait. What is wait? Waits for a packet to arrive on the bound address. See bind. Wait can't be interrupted once it's been called. This can be worked around by allowing the other party to send a specific death bill packet like this. Oh, so like a close connection kind of thing. letting the server know that you want to close the connection. That's interesting. Okay. Wait, so it can't be interrupted once it's being called. Would that possibly make it blocking? Or is it just that it's going to be waiting on? Because, like, I mean, I'm not spawning this on a different thread, which, by the way, I need to look into threading as well. How threading is handled. That's one of the more, oops. Okay, that's one of the more advanced scripting things in Godot. So, like, I'll look into that later on. I'm not in too much of a hurry for it right now. But yeah, okay. So, bind. I'm trying to remember if... Dude, yeah, okay. So even a UDP thing doesn't need to be bound, right? A UDP socket server, it doesn't need to bind to a specific... Does it? I'm trying to remember if it needs to bind. I honestly cannot remember if it needs to bind. I also cannot remember if you need to. Because, like, okay. Listen in C# is mainly used for connection-oriented protocols. Or in this specific case, I'm talking about TCP. It's used for... You use it for TCP, you don't... I'm trying to remember this because I haven't touched socket networking in a while, and then, like, because of that I can't really remember. But I believe there is... Well, I don't know why I'm trying to compare it to C# because, like, both of these have, like, their own implementations, their own ways of handling of setting things up. So, like, there's a decent chance that Godot has done, like, a lot of the boilerplate stuff. Yeah, no, I need to... Okay, hold on. Binds the packet peer UDP to the specified port and bind address with a buffer size, allowing it to receive incoming packets. If the bind address is set to so-and-so, the peer will be bound on all available addresses, both IPv4 and IPv6. If the bind address is set to so-and-so, it'll be bound to all available addresses matching the IP type. If the bind address is set to any valid address, the peer will only be bound to the interface with that address, or fail if no interface with the given address exists. Okay, now on the UDP server side, man, it's becoming kind of hard to talk. Okay, we can keep going for a little bit. Let me hydrate, and then I'll carry on. Okay, let's read this again. So after starting the server, using listen, and listen is only done once, right? What is that number there for? Is that... Okay, so that's the port, and then the bind address, there is a default value. Okay. Starts the server by opening a UDP socket listening on the given port. You can optionally specify a bind address to only listen for packets sent to that address. Okay. All right. Okay, so listen is... It's like a wrapper around bind. Actually, no. Maybe it's doing some more stuff as well. Maybe it's doing certain things that are like specific to the way that this UDP server works. Maybe, I don't know. I'll have to see. The good thing is I could probably just look at the code. You know what? Let me try that out. Hold on. So Godot has its source code online. What am I looking for? I'm looking for UDP server. I'm looking for the UDP server implementation. Okay, so I know I said I would go for a little longer, but I don't think that's a good idea. So I'm gonna carry on. I'm gonna carry on reading this, and experimenting with the UDP server and with Packet Peer UDP. I will hopefully stream again in like 6 hours, maybe. Hopefully, I'll see what the situation is with my voice. But yeah, dude, that's gonna be it for now. I hope you guys have a nice day, and I will see you all next time. Peace.